Good evening friends. Today I will discuss about the resistance in series and parallel. So before going to derive the formula for the resistances in series and parallel, I would like to tell what do you mean by resistance, what do you mean by resistors. Resistor is nothing but it can be defined as the opposition offered by the material to flow the current through it. Yes or no? So this is the simply opposition offered by the material to flow the current through it. So before going to derive the formula resistance series and parallel, I would like to tell from the Ohm's law we have V is equal to IR. Already I have told you in the last previous video that V is equal to IR. In the last video I have derived the formula for the Ohm's law V is equal to IR. From there we can write here that R is equal to V by I, or also we can write here that I is equal to V by R. So all are similar. Next means we have to derive the formula for the resistance in series and parallel. First we'll discuss about the resistance in series. So whenever the resistors are connected in series, then what will happen? So let us discuss. So we have the two resistors. We are taking only two resistors. Suppose this is R1 and this is R2. We have taken two resistors. This is the R1 and this is R2, and the current is flowing here. The current is I current is flowing. So we know that in the whenever the resistances are connected in series, the current will be same throughout. Means suppose the current is flowing here I, same current will flow through here, and same current will flow through here. Means current will not change throughout the network, but the voltage will change. So we can write here this is V1 and this is V2. So this is voltage V1 and V2. So suppose consider that R1 and R2 carrying the current I with where respective voltage drop V1 and V2 respectively, such as we know that from the Ohm's law we have the formula that V is equal to IR. Yes or no? V is equal to IR we have. So total voltage means total voltage how much? Suppose we are taking the total voltage VT. VT is equal to V1 plus V2. Yes or no? We can write here that VT means total voltage. Suppose this is V1 V2 for the R1 and V2 for the R2. So we can write here total voltage V1 plus V2. So VT means what the formula for V is equal to IR. Why the current is similar? Means current is I. Yes or no? IR means IR. Okay, is equal to V1. V1 means I is similar, that IR1 plus V2 IR2 from the Ohm's law. So I is common, we can take here I as common. From the second I can take common here. IR will written here, I is here, means R1 plus R2. Yes or no? So I will get cancel here, means R is equal to R1 plus R2. Yes or no? So total resistance, the equivalent resistance came R1 plus R2 for the network. Similarly, when a number of resistance are connected in series, then the equivalent resistance will be what? Means there we can write here R equivalent is equal to R1 plus R2 plus R3 up to Rn. Yes or no? We can write here like that. Suppose this is R1, this is R2, this is R3, this is R1. So already we have derived for the two resistances when connected in series. So R equivalent is R1 plus R2. For the R equivalent, when number of resistances are connected in series, so we have written R1 plus R2 plus R3 up to Rn, because number of resistance is the Rn. So all are connected in series. Similarly, when the resistors are connected in parallel, so on that time, suppose we have taken the two resistances. Suppose if we are taking the two resistance, suppose this is R1, this is R2. this is R1, this is R2. Yes or no? Here the supply, that current is flowing through the, this is the I, this is the I current is flowing. So here two branches are there, one branch is here, second branch is there. So two branches means two current will flow. This is I1, this is I2. But the supply that we have given, that is the same supply is having here. So from the Ohm's law we have the formula that V is equal to IR. So from the Ohm's law we have the V is equal to IR. So we can write here I is equal to V by R. Yes or no? We have written here I taken here I, if you have to find out I is equal to V by R, we have written here. So the total current is flowing through the, in this network, that I is equal to I1 plus I2. Yes or no? I is equal to I1 plus I2. What is the formula of I? I is equal to V by R. Yes or no? V by R means I already have told you the voltage source is similar for the same for this given network, means I is equal to V by R, means V by R1. Yes or no? Means here we written I1. If we are writing for the I1 is equal to V by R1, for this one V by R2. Yes or no? So from there we can write here that V by R, and we can take outside common, then 1 by R1 plus 1 by R2. Yes or no? So let it cancel here, means 1 by R is equal to 1 by R is equal to 1 by R1 plus 1 by R2. Yes or no? For the two resistance when it is connected in parallel, when the number of resistance, when n number of resistance are connected in parallel, when n number of resistance are connected in parallel, then the equivalent resistance 1 by R equivalent resistance will be equal to 1 by R1 plus 1 by R2 plus up to 1 by Rn. So this is for the when n number of resistance are connected in parallel. So this is the formula for the formula and the derivations of the when number of resistances connected in parallel and series. So these all are the very important and basics for the electrical engineers and for the class 12th and class 10th students. So please refer. Thank you.